everyone. This is example 7 from chapter 13 of your student packet. It says direct mail advertisers send solicitations to thousands of potential customers in the hope that some will buy the company's product. The response rate usually is quite low. Suppose a company wants to test the response to a new flyer and sends it to 1,000 people randomly selected from their mailing list of over 200,000 people. They get 123 orders from the recipients. So we are eventually going to create a confidence interval here, which is the second part of chapter 13. But the assumptions and conditions for confidence intervals for proportions are exactly the same as those for the sampling distributions of proportions. So we're going to check these conditions quick. The first is that the sample must be random. So that is done. The sample is random. It says it's random. We randomly selected. So sample is random. We are taking a sample of 1,000 people, which is less than 10% of 200,000. 10% of 200,000 is 20,000. So 1,000 is less than 10% of 200,000. So our 10% condition has been met. And since the sample is random and the 10% condition is met, that means that the individuals within the sample are most likely, I cannot spell here, are most likely independent. And then finally, we need the success-failure condition. So it tells us right here that they have a success of 123 orders. So the number of successes is equal to 123, which means the number of failures is going to equal that total 1,000 minus 123, which is 877. So we need more than 10, so we've definitely met that condition. So now for part B, we're going to create a 90% confidence interval for the percentage of people the company contacts that may buy something. So what is a confidence interval? So I want to remind you back when we were looking at sampling distributions that we were looking at a whole bunch of samples, and most of those samples were hovering around that average sample proportion, which turned out to be our true population proportion. So if we said that there was an interval that contained 90% of the sample proportions that were hovering around this population proportion. But what if we kind of turn that around and said, what if we can only take one sample? Taking a sample is expensive. It takes a lot of labor, and it's difficult to do, and it's definitely difficult to get a really, really good sample. So we don't have the means of getting thousands and thousands of samples so that we can find the average. Well, if we can only take one sample, then we're kind of flipping this around and saying that what is the interval where there's a 90% chance that the true proportion is within that interval. So I know that in other videos they're showing you how to do this by hand, which is important to understand, but I'm not going to do that because I want to emphasize to you that you should be using your calculator for all of Unit 3 to find the confidence intervals and in the future run tests. So please use the functions in your calculator. So in your calculator, we are going to use the function of a 1 proportion z test. Z interval. So we're going to do a 1 proportion Z interval. And the reason it's called a Z interval is because we're using the normal model. And remember, with a normal model, we calculate Z-scores. So you're going to use your calculator and go to Stat, and then arrow over to Tests. And then you're going to choose 1 prop Z int. And it's going to give you some things that you have to input. The first thing is an X value, and the next thing is an N value. This X over N is your proportion. So X is the numerator of your proportion. So in this case, it's the number of successes, 123 out of 1,000. And then it's going to ask you for a C level. The C level is your confidence level. So in this case, it's asking for 90%. So we're going to use 0.9. And then you should get an output from your calculator of 0.10592 and 0.14008. So what does this mean? This part C says interpret the interval in the context of the problem. So this means that we are 90% confident that the population proportion of, in this case, people that the company contacted who actually buy something. So the population proportion of people the company contacted who may buy something is between, so now I'm going to round these and write them as percentages. So this is between 10.6% and 14%. So finally, for part D, it says the company must decide whether to now do a mass mailing. The mailing won't be cost effective unless it produces at least a 5% return. What does your confidence interval suggest? So notice that our confidence interval, the entire interval, is above 5%. We're saying that we're most likely going to get a return of somewhere between 10.6% and 14%. So this is suggesting that the company should do the mass mailing. So the company should do the mass mailing since the entire interval is above that 5% threshold.